All right, Precalc, we're moving into circles and parabolas, and this stuff is really fun, but you will probably want to come back and get to parabolas because parabolas are the hard ones. So we're just going to start with circles today, and then we'll move into parabolas. Our essential question is, how do you recognize each conic section and solve problems involving parabolas? I will try to put up a video that talks about conic sections and why they are called conic sections. In the meantime, I'm going to do the best I can to draw an upside down cone with a right side up cone and show you why conic sections happen. If I am to intersect this conic section with a plane, if I'm straight on, it's going to make a circle. That looks like an ellipse, but that's going to make a circle. Now, the nice thing is I could just take all this away. If I do it crooked with a plane, this makes a parabola on the side. So I know my artwork isn't much to be said for, but that's where we get circles and parabolas, and they're called conic sections. All right, let's talk about circles. X minus h quantity squared plus y minus k quantity squared is equal to r squared. Notice the hk is the center of the circle, and the r is the radius. So if I have this form right here, x squared plus y squared equals r squared, that is just saying that the center is going through the origin at 0, 0. So let's start with some of these fun questions that the book gives us. It says the point -1, that's not a -1, the point 1, -2 lies on the circle whose center is at -3, -5. So the first thing we have to realize is that this is a circle. It says, write the standard form of the equation of a circle, and we're going to use this form because the 3 will be the h, the 5 will be the k, and because we're given a point, I know a point is an x and a y. So I'm going to plug that into that form. Well, if x is 1 minus h is -3 squared plus y is -2 minus -5 is the k squared, that's going to give me r squared. Well, 1 plus 3 is 4. 4 squared is 16. -2 plus 5 is 3. 3 squared is 9. We know that r squared is equal to 25. So to answer this, I want to put it back into this equation. I need an x. I know my h was -3, so that will be +3. I need my y. I know my k was -5, so that'll be +5. And because I'm given the r squared, in this case the r squared is 25. So my answer to this is x plus 3 quantity squared plus y plus 5 quantity squared equals 25. All right, the next one says sketch the circle given by the equation. Well, I notice that I have some x terms here. I also notice that I have some y terms here. And I have lonely constant. So what I'm going to do is I'm going to put the x terms together and complete the square. I'm going to put the y terms together and complete the square. Yes, completing the square is an algebra 2 term. And I'm going to bring the constant over, but don't forget I had to complete both squares. Now, the reason we're doing this is because we want to go ahead and make a perfect circle. X squared minus 2x, well, half of -2 is -1, squared is 1. What I add to one side, I add to the other. Half of -4, this is completing the square. If you need to see the video, go to my Algebra 2 playlist, and I believe it's in chapter 7-2. It's called Completing the Square. Half of -4 is 2. 2 squared is 4. And the reason we complete the square is we want to make things perfect squares. I forgot to add the 4 over. So we know that x squared minus 2x plus 1 is a perfect square of x plus 1, x plus 1. But notice I show that to the second power. We also know that y squared minus 4y plus 4 is y minus 2, y minus 2. But I show that to the second power as well. And 4 plus 1 plus 4 is going to give me my radius squared. All right, did you see a mistake that I made? This should be a minus because of this negative right here, so this should be minus. So let's go and continue. The center is at positive 1, positive 2. My radius, because this is the radius squared, is just going to be 3. So when I graph this, I have to graph this at positive 1, positive 2. I'm going to go 3 to the right, 3 to the top, 3 to the left, and 3 down. And then I'm just going to draw my circle the best I can. I'm not a very good artist, but I try. All right, the next one's a little bit different. It's asking us to find the x and y intercepts of the graph of the circle given by the equation x plus 2 quantity squared plus y minus 1 quantity squared is equal to 10. Well, remember that the x-intercepts are when y is equal to 0, and there could be 2. And the y-intercepts are when x is equal to 0, and there could be 2, and I'm just lining it up because that's what could happen. So I'm going to start by plugging in 0 for my x. So if I plug in 0, well, I can just solve this, right? So notice I have 4 plus y minus 1 quantity squared equals 10. And I'm just going to solve by bringing that 4 over. Y minus 1 quantity squared equals 6. And when I take the square root of each side, anytime I'm solving for an x or a y squared, I do need a plus or minus. And y is equal to 1 plus or minus root 6. So I'll put 1 plus root 6, 1 minus root 6. Now, if you need a reminder of how to do this, again, look at my Algebra 2 videos. This is lesson 7.1 in my Algebra 2 playlist on my YouTube channel. All right, moving on. Now I'm going to put in 0 for my y. So I have x plus 2 quantity squared plus y minus 1 quantity squared is equal, but I didn't have y. I need a 0, is equal to 10. So this is 1 squared, which is 1. X plus 2, quantity squared, plus 1 is equal to 10. Subtract that 1 over. X plus 2, quantity squared, is equal to 9. When I take the square root of each side, square root, I do need a plus and minus, so this will be x plus 2 is equal to plus or minus 3. And when I subtract 2 over, negative 2 plus 3 is 1. Negative 2 minus 3 is negative 5. So all of my intercepts are 1, 0, negative 5, 0, 0, 1 plus root 6, 0, and 1 minus root 6.